Hi, I'm Fitz Stein. Without my partner Graham, I'm doing the 2006 AP Chem Free Response question number 1. The first question, a saturated solution is prepared by adding excess Pb2 to distilled water to form 1 liter of solution at 25 degrees Celsius. The concentration of Pb2 plus is a saturated solution is found to be 1.3 times 10 to the negative third molarity. The chemical equation for the dissolution of Pb2 solid in water is shown below. PbI2 solid makes PbI2 plus 2I minus. So the equilibrium constant expression for this equation is KSP would equal Pb2 plus times I minus squared. Products over reactants. However, we can't use the reactants because PbI2 is a solid. So it's just PbI2 plus and I minus squared. Notice that the 2 out in front of I minus makes squared. Second question, the molarity concentration of I minus in the solution. So we know that because of the solution, we know that I minus will make an I equals 2B plus. Therefore, 2 times 1.3 times 10 to the negative third molarity will give you 2.6 times 10 to the negative 3 molarity for I. So the molar concentration is 2.6 times 10 to the negative 3. Moving on to calculate the volume of the equilibrium constant. After using whichever way you look at it, you could use your ice. You could just look at it and know that you have a certain 1.3 times 10 to the negative third molarity for Pb, and then you know that we've got I minus squared. And so you just multiply the two together, you can get 2.6, which was our value, squared, because it's the 2 in front of the I, times 1.3. Either way, your answer is 8.8 times 10 to the negative 4 will give you the final KSP. Moving on, a saturated solution is prepared by adding PbI2 solid to distilled water to form 2 liters of solution at 25 degrees Celsius. What are the molar concentrations of Pb2 plus and I minus in the solution? So, after looking at that, we know that there's going to be no change to the entire concentration of both Pb2 plus and I minus because the saturated solution with the concentration of solute particles is independent of the volume. We know that adding water to the entire concentration won't have an effect on either solution. So, in the end, there's going to be no change to either concentrations. Moving on to C, solid Na, you can cross the Na out, solid I is added to a saturated solution of Pbi squared at 25 degrees Celsius. In assuming that the volume in the solution does not change, does the molar concentration of Pb2 in the solution increase, decrease, or remain the same? Justifying our answer, we know that NaI dissolves, and NaI will dissolve, which will cause I to increase. So knowing that I will increase, the Pb2 plus will have to decrease in order to remain the entire concentration to create equilibrium. Kind of like Le Chatelier's principle, we know that if one decreases, one will have to increase in order to create equilibrium. For moving on to D, the value of KSP for the salt, BaCrO4 minus, is 1.2 times 10 to the negative 10. When a 500 milliliter sample of 8.2 times 10 to the negative 6 molarity BaNO3 is added to 500 milliliters of 8.2 times 10 to the negative 6 m, no precipitate is observed. So, assuming that the volumes are additive, they calculate the molar concentration of Ba2 plus and CrO4 in that 1 milliliter solution. Okay, so moving on, we know that there's 500 milliliters of BaNO3 and there's 500 milliliters of Na2CrO4. So we can do M1V1 equals M2V2, and we know that 500 milliliters times 8.2 times 10 to the negative 6 molarity will equal 8.2 times 10 to the 6 molarity times a total volume of 1,000 milliliters. So in the end, our answer for Ba2 plus is just 4.1 times 10 to the negative 6. Next, 500 milliliters times 8.2 times 10 to the negative 6 molarity will equal 8.2 times 10 to the 6 molarity times the entire volume of 1,000. Same thing as we did for Ba2 plus. Because the two molar concentrations are the same, they're going to equal the same molarity of 4.1 times 10 to the negative 6. For our last question, use the molar concentrations of Ba2 plus and ions CrO42 minus ions as determined above to show why a precipitate does not form. You must include calculations for the answer. So for our final answer, we have the Q equals Ba2 plus times CrO42 minus, and we know that our previous calculations has 4.1 times 10 to the negative 6 as the molar concentration. So multiplying those two together, we get 1.7 times 10 to the negative 11th molarity for Q. And now, comparing the two together, our KSP, which was given in the previous problem, says right there 1.2 times 10 to the negative 10th is our KSP for the salt. We know that the Q is less than the KSP, which will cause a precipitate not to form. So, precipitate doesn't form, and that's all of our answers.